What's up, guys, and welcome back to another episode here on Archi-Tech Network. And today we are going to be discussing the topics of space architecture and 3D printing. And we're going to be discussing these with a real-life space architect, Melodie Yashar, who works at the 3D printing company ICON. Now, if you've never heard of ICON before, as I say, they're a 3D printing company based in Texas. They're literally cowboys 3D printing buildings today. Super interesting company. I've put their website in the link below so you can check them out. But they've been collaborating with us at BIG and NASA to design and build homes on the moon and Mars, as well as here on Earth. And we're going to be discussing with Melodie how she got into space architecture, the emergence of 3D printing, and how it's going to disrupt our industry and us as architects, and connecting us back with the act of making, potentially bringing us back to being master builders, as well as the challenges of 3D printing here on Earth, but also extraterrestrially. And finally, how you yourself can move your career towards being a space architect. As always, if you enjoy these talks, give us a like and give us a subscribe. You can follow us on Instagram for upcoming talks. And of course, if you enjoy this, please do share this with friends and colleagues. The whole point of these talks is to share knowledge around architecture and technology. And I think space architecture and 3D printing is perfectly in that intersection. Without any further ado, let's jump into it and let's get started and have a chat with Melodie. All right, that's it. We're live. Melodie, thank you so much for joining us today. It's a pleasure to have you on.
Ollie, thank you so much. It's a pleasure being here.
Awesome. Yeah, no, I thought it was a really interesting time to have you on. I think there's some really cool stuff going on with ICON. Off planet, on planet, and also a little bit of stuff that I've been doing in the world of space architecture as well. So I thought it was wicked to have you on. Let me give you a little bit of an introduction to the audience that don't know you already. Just some kind of like bullet points that I found from researching into it a little bit. So you are a space architect. I love that name. I think we should see more space architects as a title. You're currently the VP of Building Design and Performance at ICON. You're also the co-founder of SEARC, which is Space Exploration Architecture. And you kind of got this really interesting background of different things you've been doing. You've worked as a designer, as an architect. You've been a researcher at different places, including NASA, which is very cool. And also you're teaching. You've been a professor at various different universities. So you've got a really mixed background, which I thought was really interesting. So yeah, thanks again for joining. Like I said, I think it's a really interesting time of what's going on at ICON recently, right? You've just landed some funding from NASA to kind of take Project Olympus to the next level or next kind of stage in making that become a reality. But on planet, we're seeing ICON print or like develop their first kind of 3D printed development in Austin, right? The what was it called again? Wolf Ranch.
Wolf Ranch, yes.
Yeah, and so lots going on off planet, on planet. We had like Julian from Big on one of our earlier podcasts, where he's kind of our space architect in Big, that he does most of our projects. And so that was a really good, this was back in the day when we were on Clubhouse, and that was one of our popular talks. I really enjoyed it. And also I have been venturing into the world of space recently. I've just been teaching at IAC, this module called Smart Construction and BIM. And all the students, traditionally this module, all the students did something like off planet. And so before they did the moon, and then they did something that like revolved around the moon. And this year we decided to go to Mars. So I thought all of these things were coming together. So I thought it was a perfect time to have a chat with you.
Oh, great. I love that.
Yeah, it seems like such an exciting space, like 3D printing and this new space race. So yeah, thank you so much for joining. I think the first thing we should jump into is how you got into space architecture, because I've got a lot of like, I talk to a lot of students, and I usually present about how, we work with design technology at Big, and, whether that's like things like BIM and computation, but I also talk about how technology influences design, and you see the emergence of 3D printing, and this is also very linked to the space race. And they always ask, like, how do I get into space architecture? And is this a thing right now? And do you see people like, hiring space architects? So how did you become a space architect?
Yeah, it was a very natural evolution and it was a very kind of there wasn't a grand plan to apply for available space architect jobs online and then like have the resume to do it. Like that just didn't really exist. That wasn't really part of just wasn't in our consciousness at the time, right? Yeah. So essentially, I started out, in addition to some others that I had met and who were my former colleagues from Columbia University, as a competitor within NASA's 3D Printed Habitat Challenge. That was the first phase of NASA's Centennial Challenge where there was a public solicitation to design a Mars habitat. And so myself and a few others from university and some friends of ours came together, and it was really a nights and weekends project. We all had day jobs, right? And we submitted to the competition. That's where the magic
happens, right?
Yeah, right. Like that's where you really explore new ideas that you otherwise wouldn't be paid to do, right?
Yeah.
At least not yet. So we submitted to the competition and we won first prize for a project called Mars Ice House. After then, we started to, more or less people started reaching out to us. We started to receive phone calls, emails about our work. Search plus space exploration architecture was incorporated as a direct result of competing in the NASA Centennial Challenge. We won an award and we thought, hey, that's a good enough reason to incorporate as a company. But it really, Search kind of evolved into an applied research practice for space architecture. Search and Clouds AO, which is a firm based in New York. We competed in the Centennial Challenge in phase 1. We were very fortunate to be connected with a group out of NASA Langley who was interested in developing the concept further. And thanks to multiple rounds of funding that they received, we were able to do some materials development for an ice home concept, as well as some additional schematic level design that somehow spun off into a concept for the NASA Big Ideas Challenge. So these concepts have been influential in their own way, but also have naturally evolved and sort of transformed into something new. People take interest in the idea, and there's an energy and there's a forcing function behind believing in this vision of extraplanetary living, and people really latch onto it, right? It sort of things kind of amalgamate in that way. And then so Search for the next several years was a consultant for multiple aerospace companies like UTIS, where we were looking at interior habitation as well as encasement and I guess general kind of massing for their ecosystems. And then we competed again in the Centennial Challenge, this time collaborating with APIS Core. We were very successful in phase 2 and phase 3 of the competition. And thanks to that, we're able to be recognized by the Marshall Space Flight Center group that was focused on in-space manufacturing, generally speaking.
Right.
Both Search and ICON were recognized as finalists from the competition at the time. And that was how I was actually introduced to Jason Ballard, the CEO of ICON, via our colleague at NASA Marshall. Search then consulted for ICON over the course of a year and a half, again on Project Olympus, actually, where we came up with a space architecture proposal as well as a concept for developing a lunar base and a lot of fundamental research surrounding that. and then a short while after, I resigned from Search and received an offer to establish an architecture and develop an architecture department at ICON, which has been a wild ride and really inspiring and a lot of fun to be a part of. So that's like a abbreviated history of how I became a space architect.
Yeah. No, it's a really interesting story. It's kind of it's like a dream story about, I assume these things at the beginning were, they were just competitions, right? And that, a lot of architects start out doing competitions, but there's something in, like proposing something so new and innovative like space architecture. I think at the time, I'm sure there weren't that many competitions that you saw that kind of stuff. Whereas now you see a lot more, like what I call ideas competitions for that kind of stuff. But to do a few products and then immediately it turns into like a small firm and then it kind of snowballs from there is kind of like a really nice story of like the power of competition sometimes. Like sometimes they're a good thing, sometimes they're not so good in the industry. But, it's a really nice story about how that kind of evolved.
I think more than anything, NASA really structured themselves to think of the computation as an incubator and as a way of generating ideas, crowdsourcing ideas, but also because the competition, I should say, in phases 2 and 3 was both construction technology development and construction prototyping, as well as design, hand in hand. Design, but supported by construction demonstrations. They really saw themselves as like an accelerator for showing the state of the art and representing the state of the art in 3D printing. And then the design concepts would then feed into that. It would support the development of the technology and they would work hand in hand. So it's not just Search that this competition really supported and bolstered. It's ICON as well as Penn State, as well as many AI Space Factory. There were many others that had great success and sort of rode on this wave of the competition as a sort of incubator and accelerator for technology development in 3D printing. And it really established like new voices in the field, which hadn't come around, I think, for quite a bit. There is a very prolific community of space architects. There's a subcommittee within the AIAA all about space architecture, and those folks are so inspiring to me. And some of those personalities and those individuals have been in this industry for decades and decades. But thanks to the Centennial Challenge, I think you're right. Like it really did inspire this like resurgence and this interest for a new generation in what 3D printing can do and what's possible, because nobody had really been building at scale up until now, or at least I don't think so. I haven't seen the work happen in the way that I'm seeing it happen today with ICON and what we're doing.
Yeah. So now you're at ICON, which is a very cool and fun company. I was very fortunate that I used to work in a New York office for a few years, and now I'm in the London office. But I was there when Jason came in and pitched us like ICON. I think it must have been 2018, 19 or something. And for those in the audience that haven't heard of ICON or looked them up, I'll put the link in the description. But the way that I describe it is literally cowboys from Texas 3D printing, and like he's literally got his cowboy hat and everything, and he's a very interesting character. So at ICON,
Jason's a space cowboy. If I'm a space architect, Jason's a space cowboy. We all work together. It's a good pair.
That was actually that was my intended motto for Burning Man. Because like the cowboy hat is quite unique for me as like a Brit. It's like a cool thing. So that was like my thing at Burning Man. I had like a cowboy hat and ski goggles, and I was like, I'm just a space architect. And it's a strange thing wearing a cowboy hat in the US when you're not from the US, because you just walk by and people call you cowboy. I'm like, hey, cowboy. You're like, what's going on? But yeah, so now you're at ICON. Are you working on both on the planet projects as well as off the planet projects, or you focus on one or the other?
Yes, I'm very fortunate to be doing both. I lead and direct all of the architectural development of our terrestrial projects. Those range for projects we're doing for the Department of Defense, in the affordable housing market, as well as for mass market housing in the residential sector, single family homes. And then, yes, I do support the work that's happening for Project Olympus and for our NASA customer, which is still Marshall Space Flight Center. And it's very exciting. It's very exciting to be the key contractor and the key firm that is going to be developing technologies that will deploy someday on the moon in collaboration with NASA.
Yeah, no, it's super interesting, and I'm fortunate that I get to see some of the projects that are not yet public that we've collaborated on, and I've been fortunate to work on them as well. And there's some really cool stuff coming for people in the audience, but we'll see when it comes out. Mm-hmm. But there's loads of things I want to pick up from that, but maybe I'll go back and talk about ICON and 3D printing and space architecture, because they're kind of very linked in that. Would you say 3D printing is the primary method at the moment that we would build on the moon or Mars? And it seems as though this new space race has accelerated the growth of 3D printing. I mean, I think when 3D printing first kind of emerged in architecture, classic architects, we got all excited and created these ridiculous Avolo-style competition ideas where skyscrapers were just monolithically printed in one go by some giant machine, and we thought of these things as really a way to print really complicated shapes. But then a few years later we started to see the ICONS and other 3D printing companies actually printing stuff, which I didn't think would happen so quickly, and I think that's a lot to do with this new space race of going back to the moon and eventually Mars. Where do you see that we are in the world of the 3D printing hype curve? Every technology goes through the hype curve, right? Of the initial excitement, and then there's this plateau, and then we finally get to seeing, things that are actually usable in the real world. And 3D printing, I feel, has kind of, obviously went up this hype curve, but very quickly we're seeing things like ICON, and I always use ICON as an example, where you are building this, extravagant and interesting proposals off planet, but we're also delivering affordable real homes today, which I think is really exciting. So where do you feel we sit right now in the era of 3D printing?
Yeah, I would say that terrestrially, 3D printing is basically here, and it is I don't think it's any longer, I wouldn't call it an emerging technology any longer. I wouldn't even call it an up and coming technology. It is very much a mobilized and effective solution to automating home construction and any kind of construction, frankly. And it introduces significant benefits and efficiencies that you just don't get with traditional labor and working with materials and means and methods of construction as you typically would. Right. The difference, though, that I see, as I see it really, is that when we talk about in-space construction or in-space manufacturing, there really are no other alternatives. When we're talking about creating infrastructure on the moon and Mars, when we're talking about deploying systems that will create that will construct habitats autonomously, because hopefully all of this will happen before anybody is even there.
That's the mind blowing part. I think people don't get. We'll swing back to that, but
right. The truth is that in space you have nothing. You have no construction crews, no contractors. You have no support. There's no other option. terrestrially works, like 3D printing is here as a way of thinking smarter and more efficiently about means and methods of construction, thinking more sustainably about materials usage, about labor shortages, and how we can build more interesting and more versatile geometries without added time or cost. In space, it's really, and it's a matter of it's almost essential. Like, you have no other way of building vertically. Like, there's no other solution. Like, you don't have people to go lay down bricks unless you want to design a robot to do that. So in space, you have to be thinking about how robots can essentially perform their tasks autonomously and without a human in the loop or without human intervention. And 3D printing has become so interesting and so appealing as a solution to this, because you can essentially print any kind of structure or any kind of geometry on demand without, again, added cost or time. So 3D printing, I think, is the poster child for off-world construction for that reason, because you can print, hopefully, anything within the imagination, within the constraints of gravity, if you're working under gravity. And that's really the idea, is that you would send over a single construction system to create all kinds of infrastructure that you would need in space, rather than sending multiple robotic systems that would have to each do an individual task. Separate
things. Interesting, yeah. It's actually the 3D printing part I can envision. It's the, like, when I first started to envision, like, space architecture and understand it, I always kind of thought, oh, a space crew turns up and the machines and everything turns up as well, and they have a little space tent or whatever that they're just hanging out in whilst things getting built. But that's not the intention at all, right? It's like these things land, they go off and print and build on their own. That's the part that seems like mind-blowing for me, because I look at just how we build homes here on Earth, and that on Earth seems like almost impossible. So that's the thing that that kind of blows my mind. So is that something that you guys assume will have to test on Earth before, you just don't touch the site? It's kind of like completely raw, and you got to send these things out on Earth and they just print themselves.
Oh, absolutely. Yeah. Earth will always be the test bed before deploying these systems. Systems as complex as this in space. Yeah, I mean, space technology development is all about mitigating risks. If you look at the ISS and the way that spacewalks happen, or anything that happens outside of that's extravehicular to the ISS, these astronauts are inside very bulky suits. They have limited range of motion, limited dexterity. They can't really do a lot with their bodies or their hands. And so it's incredibly dangerous. We're trying to limit the amount of risk that we're introducing by having astronauts do arduous tasks like construction, and then consider what that would mean for a crew of 2 to actually create their own habitat using their bare hands and using materials that they would either bring from Earth or source locally. It's quite a task. We haven't really done comparable work in space, so there's no precedent for it. This is why we're really leaning into the potential of robotic construction to actually solve this problem for us, mitigate the risk to human safety, and hopefully introduce construction elements and structures even before the crew is there, because it can happen in an autonomous way.
Yeah, that's awesome. And another question that I hear a lot of people always ask about space exploration and building on the moon or Mars is why are we putting resources into going off planet when we have so many things off planet? And that the answer to that is kind of obvious to you and I, but I think that kind of illustrates it, is that so many of these technologies filter back down onto Earth, and again, I think you see that now really well with Icon. You're simultaneously, developing these systems off planet, but you're also seeing these on planet with, the development of your first 3D printed multi-home kind of development. So, I mean, that's one question I get also asked all the time. I watched a couple of your videos online, and I saw people ask you that as well. I mean, it seems obvious to us maybe, but yeah, I mean, that's kind of it. Is like you're testing it on Earth, and you're developing products simultaneously right now in space and Earth, right?
Yeah, I mean, it's an extremely warranted question, right? Like, on the surface of it, space technology development is not directly resolving specific problems that we face on Earth, right? Like, it's not a direct resolution to those problems. But what I found is that the framework of designing for the extreme environment of space actually brings back so much value to how it is that we design for Earth, and we introduce solutions related to technologies for Earth. And that it's a mindset that introduces all kinds of efficiencies in how we think about materials, how we think about redundant systems, how we think about reliability, sustainability in space. And all of that is absolutely essential to the way that we approach construction on Earth. And I hope, frankly, that more builders, more architects, and more folks involved in materials development and engineering on Earth were to think that way. Because the truth is that, like, we are actually fairly resource constrained. If we think holistically and comprehensively about what it is, the impact that construction is making to Earth, like, overall, we have to be conscious of the fact that we are resource constrained, and we should be doing things smarter than we are right now. So yeah, the sustainable argument, it comes back through and through. Like, we have to be working smarter and introducing better ways of solving the construction problems that we have.
Yeah. So what do you feel are the biggest, like, constraints right now with 3D printing, and what innovations are kind of like the things, what innovations on the horizon do we need to tackle to kind of take 3D printing to the next level? Like, obviously materials is a big part of 3D printing. Right now you're mostly 3D printing with concrete and things like that, but there's also bio-based materials in the future you'll be able to print with and all this kind of stuff. So what do you feel are the biggest constraints in the architecture, printing architecture, and what are the kind of innovations on the horizon maybe you're most excited about in the world of 3D printing?
Yeah, absolutely. I think that, for architecture, architects would, in theory, would like to be able to produce and print any kind of geometry, right? So we still have constraints relative to cantilevers and overhangs that we are making very big leaps and advancements on, but it is still a constraint. Like, can't exactly print a sphere without a good amount of structural support. So that is a limiting factor for us. But because we're predominantly working in the residential sector, our focus has been on vertical walls. So we develop vertical wall systems, and then we use traditional construction materials for roofing, and as well as for foundation systems, as well as even though we have a means of creating formwork for foundations. In the future, we are looking to 3D print the full building enclosure itself. So we'll be looking at roofing systems. We'll be developing systems to print more aggressive overhangs and cantilevers, more interesting and more courageous geometries. And that's all stuff that we're working on right now, and I'm really excited about. I think that in the broader picture of for 3D printing, and as far as the technology is concerned, I'm super excited about multi-material printing. That's a clear area of development for both Earth and space that will bring so much value. I haven't seen it happen at a building scale or at scale just yet. It's been very localized and desktop at the scale of like desktop printers only. So I'm super excited about that. And then also just like any other kind of additional automation that we can introduce to the build process, I think is super exciting. ICONS also working along those lines. Site support robotics and different capabilities for construction tasks. These are all things that we're developing in our R&D and that we're working into our building site construction sites as well.
Yeah, and that's interesting. Like the multi-material printing. I know there's one company that does 3D printing with metal. It's like oh no, I'm blanking now. 3DXN or something like that.
There's a couple, yeah.
And do you think with like, would that be what you're kind of moving towards in terms of like printing some kind of concrete material as well as structural support, like rebar kind of thing? Do you think that's something we'll see soon, or like is still a little bit of a way to go?
I think it's coming up. I think that printed concrete with printed reinforcement is definitely in coming up in the near future. We'll see it soon.
Is that the kind of main innovation that would allow you to achieve more freeform buildings, or is there any other kind of, because you guys don't do like support material so much, right? You print the concrete directly, but would going down the support material route also be viable? It seems kind of like messy in itself, and with desktop printers, it's kind of like, oh, you got support material, you have to like pry it out of the thing and make sure you don't print something that's going to like keep it all in there.
I know. I'm so glad those days of those like early polymer printers with all of the crazy supports that you have to dissolve or over. No, we're not really looking into formwork or scaffolding too much, even though it is a viable way of approaching how to print those geometries. I think that automating both reinforcement and concrete deposition will introduce a ton of efficiency just in the build process overall. Right now, we lay down reinforcement manually, so it's not automated just yet. We have a crew that's there on site who lays down reinforcement. It doesn't introduce a whole ton of time. It's not a time suck, so to speak, or time sink, so to speak. But at the same time, I do think that automating the entire procedure would be a lot smarter and over the long term would introduce an economy of scale if we were to do multiple houses, hundreds of houses. Right now, I would say that the real trick in engineering and structurally designing these like new and interesting geometries is making sure that the form factor actually works with and functions with the reinforcement strategy. So I think it's more of a design exercise than it is a technology hurdle when it comes to automation.
So form must follow function.
Yeah,
especially in space.
Right. Yeah, exactly. So there's a lot of work that remains to be done there, and it's exciting to be a part of it. And it is, you're right, it's a form finding exercise that supports both Earth and space.
And I think Project Olympus, the collaboration between us and you guys, I think is one of my favorite projects to illustrate like the combination of form, function, computation as well. Like I'm a computation nerd, so it's kind of like a scripted approach as well. Before, I know that project wasn't so public, but I think people can go online now and see, at least on Big's website, the thinking behind the shape, not only in plan but also like the section of it to deal with these new challenges that you have from printing off planet, of pressure, radiation, extreme weather, and all these kind of things. And I think it's a really cool projects to illustrate form and function, because there's not a lot of space for, no pun intended, for like flamboyant ornamentation in architecture, right? And so, one, like, do you think architects are particularly good to design on off planet? Because sometimes we do lean into, we slowly have become more image creators, whereas when you build on off planet, there's really no space for creating, a flamboyant or design that is not really functioning. And secondly, like, what are the biggest additional challenges of building off planet? I think we've mentioned maybe the key ones, like radiation, pressure, of course, and just extreme weather. And like, how do you build that into this automated system is mind blowing. But yeah, what are the biggest challenges for building on space?
Yeah, I mean, you mentioned the environmental constraints. I think are fundamental. Often, well, it comes down, I think, to the value system of an architect and what that value system is. Yeah. Is it aesthetically driven? Is it formally driven? Geometrically driven? Or can you accept the laws of physics, right? Like, relative to environmental constraints and environmental conditions, and respond to that accordingly. I think that there will always be a tension there between responding to constraints as they exist, both in terms of technology development and capabilities, but also in as far as what's like possible to build currently, right? I think space architecture hits on that tension very, very specifically. And for the architects that are like a little bit more expressive, maybe it is an opportunity to like really lean into the creative potential of what's possible. But like, I can speak for myself, like, my value system is very much like that design and resolving the structural problems as well as the human problems should go hand in hand. They should be mutually supportive. I don't necessarily, I would never subscribe to like, or adhere to like an aesthetic direction if it didn't address or resolve an underlying engineering issue in space. And I think they can do both, and they should do both. And we should strive for those areas of shared value rather than, saying that the only thing that matters is aesthetics or form or experience. No, I think that by providing a single solution, like, we have to address multiple problems, and those problems will be structural in nature. They will have to do with human health and ensuring the astronauts are protected against radiation, and all the other kinds of like human factors driven inputs that typically come up in space architecture. So it's a confluence, like a single architectural solution is a confluence of multiple issues in my mind, and should be addressing those things comprehensively. Yeah.
I'm very much on board with that philosophy, but you do make a good point. I think, I do see like people that are quite into, complex freeform geometry, or, what we call parametric architecture or curvy fluid architecture. 3D printing could be a way to make that more accessible and affordable to build, here on Earth. So you could see it become, unleash a new kind of style of this architecture to the masses. Of course, like, as an architect, the dream of 3D printing is bringing the architect back to becoming a master builder, right? That diagram of an architect with his or her laptop, and then the cable going to the machine, and it's like printing straight away. Of course, like, that's the dream. Do you think we'll see 3D printing will enable architects to get closer to being a master builder? Like, I can go and hire a 3D printer off you guys, for example, and print my works without having to kind of go to all these different trades. Do you think we'll see 3D printing bring us back to being master builders?
Yeah, I absolutely. I do believe that we at ICON, we really believe that 3D printing can enable the exploration of new divergent architectures and geometries that have never been able to be constructed before. So a lot of this like parametric form language and design language is, you're right, something that can only be done through 3D printing. And so ensuring that architects and even like homeowners have a little bit of say, I shouldn't say a little bit, architects and designers first and foremost have full reign to sort of design what they want and print and construct what they want, is definitely the end all be all goal and dream of this. And then same deal for homeowners. Like we see there being the barrier for customized homes, or like let's say unique or exquisite features that would only be possible through precast or through like highly customized like wood construction or panelized construction. Like that doesn't need to be as expensive or as prohibitive as it has been in residential construction. So like there's really no added cost, no added time for creating these new geometries for anybody within the residential sector. And that's a huge value add. Like we're going to be seeing homes that have never been built before. And I'm really excited about that.
Yeah, that's a great point. The user, like, people can customize and change the layout, and because it's all kind of automated and 3D printed, people can actually have a say of how their houses are laid out or look within reason, I guess, of course. But the other thing I think 3D printing brings is like another question I quite often get, and I'm sure you get, is like it takes away the human factor. Is like everything's generated by a computer, printed by a machine, and all this kind of stuff. But you actually do see it kind of brings you back to the tactile nature of materials, and particularly with the like how you script and code the nozzle head of like where it goes, and you get these incredible patterns of the print pattern, which I think is a really, I always use that as an example when people ask me are we losing touch with materials and like the tactile nature of things? And I think with 3D printing, you get some of the most interesting kind of materials and patterns within the 3D print, which I think is a really nice aspect of 3D printing. Not a lot of people talk about, right? That kind of like human touch.
Mm-hmm. Yeah, absolutely. I think that there's an assumption that mass production and automation is going to introduce a result that is highly, let's say, undiversified and extremely monotonous. But the reality is that, like with our system and with cementitious concrete 3D printing, like cementitious 3D printing, the material system is the structural system, and you're able to have like the natural effects of the printing is actually something that people really gravitate towards. Like there's a machine aesthetic that is extremely positive, like the colors and the striations between the beads and between the layers. Like those are things that actually people really respond to, because there's material that's like the texture and the light and the effects of the material itself are so different from what you would see in normal residential construction. I think people are very excited by it, actually. Yeah.
It's got an amazing feel to it. Every time I see one of the projects, even when we have it rendered in the office and we're walking around it in VR, it's like it's got a really amazing feel to it. Mm-hmm. Next up, what I touch on, of course, I read about you're quite interested in the intersection of design and technology, or architecture and technology. You're on the Archi-Tech channel, so we have to touch on a bit of like technology outside of 3D printing, of course, especially right now. There's so much interesting stuff going on. I mean, you've got the bread and butter of how established tools like computational design and BIM and all this stuff kind of ties into 3D printing, and that's the one way I've been able to kind of interact with the projects that we've collaborated on as kind of like the BIM side of things. But then on the kind of more experimental side, you've got the emergence of AI that's just kind of taken the world by storm, and especially a lot of people are kind of jumping onto Midjourney and exploring 3D printed habitats on Mars or Earth and, seeing what it comes up with. But is there any kind of technology that you're really excited about outside of 3D printing that could have an effect on what you're doing on Earth as well as space architecture? I think, AI is one that springs to mind. I was reading Life 3.0, the idea of what you're saying, where we send things to the moon or Mars, and we then, it automatically builds stuff for us. And a big part of that is AI, and they kind of painted this picture of like you would only need to send a probe and the machinery. You wouldn't even need to send the software with it. And once it's there, it can download the software, which you can, be updating at the same time. And then suddenly AI and robots are like building these things. But yeah, is there any particular technology that you're really excited about that's maybe emergent or super emergent that would have a profound effect on space architecture or anything else around that kind of thing?
Oh, yeah. I mean, I think you're absolutely right. AI will touch every sector of both technology as well as construction one day, very soon, if it hasn't already, in a small way. The truth is that, like, AI is introducing optimization in every sector in ways that we just have never experienced or could have anticipated before, and it's really exciting. Like it's
exciting
incredible.
And scary at the same time. I feel like every week something's coming out, and you're like, "This is incredible," but holy shit!
Yeah, I think the pace with which this is happening is what's so jarring, right? Like, my God, Chat GPT and everything and Midjourney, like having this all sort of like coalesce at the same time has been really, really interesting to witness. And it's just going to continue, frankly, I think. So, like, I'm very excited in how we can introduce, I try to, like, I really believe, like, we're going to see so much benefit in how we build and how construction happens and how architecture happens. Like, a lot of the really monotonous and, let's say, dataless processes that we have right now in design and architecture that are not really informed by information, those will change radically with AI. And I think it will I really do think it will make our jobs better. Like, it will put us in a position where we are solving critical problems and making critical decisions rather than, iterating aimlessly on a bunch of formal iterations of a floor plan, or wondering what the supply chain is for a certain product, or like why schedules are not matching up with what we had planned, and why our budgets are not lining up. Like, machine learning and AI can really help resolve a lot of those problems. So I see great opportunity there. I have no doubt that, like, for journalists and people who are in the business of image creation, like this, it is solving and it is like it is addressing a huge chunk of the labor force when it comes to, like, just image creation and production. But I don't think it's going to eliminate the craft behind what happens when you're doing CG. I don't think it's going to eliminate the craft behind, like, writing an English paper. But how exactly that plays out remains to be seen. I think, like, the regulatory environment that we're going to see emerging in the next few years is going to be very, very interesting and, frankly, controversial too.
Yeah. No, I think you've really nailed it. It's like, hopefully we'll see it automate a lot of things that we don't need to do, so we can focus on the things that we really add value as designers, as architects. So, it's a super exciting time. Like you say, all of this stuff is kind of converging at the same moment, and at the same time we're going to other planets. So yeah, it's a very exciting time. Maybe for any of the kind of young architects and students listening into this, how, could they get in or like step towards getting into space architecture or the world of 3D printing right now? Because I'm sure there's a few more opportunities now, but maybe, it's not like at a mainstream level. But what advice would you give to young students listening to this that are really interested to get into 3D printing and or space architecture?
Yeah, what I tell people and what I tell students in particular is that if you're passionate about the project, just go ahead and do it and put it out there into the world. So often these projects serve as a forcing function for how essential it is to be thinking about space and space technology development and building in space. And without visualizing those ideas, it is very difficult for people in other sectors and other disciplines to actually wrap their head around what that means. So I think architects and designers have a particular the faculty to visualize and to bring something to the mind's eye and to show that to the world within an instant. We can lean into that and the power of that. And what I've found is that it has been extremely influential and momentous to the way that technology development happens, particularly for 3D printing. Project Olympus, as an example, started with the schematic work that Big and also Search Plus had done even before a lot of the work on the SBIR had been developed. So it was almost like the vision was established through architecture. There was an idea of what space architecture and a space habitat and a lunar base would be, and then it informed the technology development requirements, and the technology kind of responded in turn. It was like a call and response, right? And I think students are very much capable of doing the same by putting your ideas out there, by sharing a vision of what the future could be like, living on another planet. It will serve as a forcing function for others to then respond to, and who knows what could come from it.
Yeah. No, I think that's a really nice, it's kind of a nice way to kind of close the loop of how you started, and passing it on to other people is put your ideas out there, and look at what's happened for you. You're now on the way to the moon or Mars. If you had the opportunity, would you go yourself?
I say this to people a lot. I would go to the moon in a heartbeat. Mars, I'm not so sure. I really am not so sure. I think I would want to know that there is a guaranteed trip back, and
two-way ticket.
Yeah, exactly. And there's just so much that we don't know about that journey and what it's going to be like, and whether it's even safe from a human perspective. So I think I would try an analog mission first before even contemplating a full journey to Mars and back. But I don't think I would do a one-way ticket to Mars. No.
Okay, well, we'll see in the future. Are you guys or NASA still looking for volunteers for the Chapia? Or I don't know what it's called. Not an experiment, but
it's an analog project. They chose the first crew actually, and I believe the simulation, the experiment, should be starting this year, in the next few months. But they will have an open call for future missions. So I'm guessing it would be sometime this year. They would have another call for their second mission, which would be the second year of the experiment.
Cool. So anyone listening, if you want to hang out in a Mars house for a few
designed by Big and ICONS.
Designed by Big, then sign up and check it out. But I think that's a really nice place to end the podcast, we always ask guests if there's anything that might be coming up, or if people want to reach out to you and maybe ask you questions, or what's the best way to contact you? And do you have anything coming up, any talks or online courses, or projects that are emerging that you want to let people know about?
Let's see. Well, you can definitely check out iconbuild.com. There's lots of information about our current projects, past projects, and things that we have coming down the pipeline. We're going to be opening up reservations for the Wolf Ranch homes soon, so that's also very exciting. You can purchase a 3D printed home designed by Big. Like, when in the world has that been a possibility, that you can put your name down and take a reservation for a home designed by Big? That I'm very excited about that. Of course, you can check out my personal work on my website. It's melodieyashar.com. You can reach out to me there. And Icon and my team and Big, we're going to be announcing some exciting stuff coming up in the next few months very soon. So more coming. Stay tuned.
Stay tuned, yeah. We'll put all of your links in the description below, so anyone listening, you can check it out down there. But thank you so much for joining. I think there's already more questions I want to ask, but I think we'll save it for like a part 2 down the line when we've got even more to touch on. But thank you so much. I think this will be an exciting talk. It's one that we keep talking about. 3D printing, Icon keeps coming up in discussions, so I think it's really interesting. We'll be back in a couple of weeks with another podcast. We haven't got a guest yet, but we will work it out. We'll stay on planet for the next one. But yeah, thank you so much again for joining. And hopefully we'll have you on again in the future to talk about all the amazing things you're doing.
Definitely. Thanks so much for having me. This was fun.
Great. All right. We'll see you on the next episode, guys.